Hi, this is the third video in the LinuxFu series, taking you from beginner to guru. In this episode we'll be looking at navigating the file system, permissions, and a couple of useful commands for you to try. In the previous LinuxFu videos, we took a look at what Linux is, a bit of history, why Linux has become so popular with embedded systems, then moved on to how Linux boots and the file system layout. Linux has two ways of referencing the file system, absolute and relative. Absolute references are of this form, while relative references take this form. Within every directory there are two special directories called dot and dot dot, which are used for relative referencing. Dot refers to the current directory, while dot dot refers to the parent directory. You can use any combination of relative and absolute references. For example, this would simply resolve to /usr, /local, /etc. Relative references can be as long as you like, but can quickly get out of hand. Moving around directories is as easy enough using the command cd. As with any command, you can use absolute or relative addressing. To create a directory, use mkdir, and rmdir will remove a directory, unless there's something already in there, in which case Linux will stop you from doing it. If you want to find out which directory you are currently in, use pwd, although most Linux shells will show this in the shell prompt. Listing the contents of a directory is as easy with ls, which will default to the current directory, or dot, or of course using absolute or relative addressing. Every command or executable under Linux can take arguments or flags. We'll be looking at the shell more in depth in a later video, but for now here's some common flags for ls that you might use. The -l flag will provide more detailed information, while the -a flag will show normally hidden files or dot files, starting with a dot. Adding a -F flag will add a symbol at the end of every file and directory showing what it is. This is useful for condensing large directories. Be careful when you have files or directories created with a space in them. Unix treats a space as an argument delimiter. So how do you access these? There are two ways. One, wrap the directory or file name with single or double quotes. Two, prefix every space with a /, or also referred to as an escape, or a backward slash. With the ls-l command, you will have noticed a few things. There are 7 columns of information that are provided. Working from right to left, there is the file name, the modification date, the file size, the group owner, the user ownership, the number of file or directory links, which we will look at later, and the file permissions and file type. This column contains some important information, with the first character showing the file type, and can be a dash for ordinary file, D for directory, L for symbolic link, which is a reference to another file, C or B for character or device file. Remember, everything is a file under Unix. P for a named pipe, which is a way for one process to send output to another process. S for a socket, which is similar to a named pipe, but allows bidirectional communication. The next 9 characters are grouped into 3 sections of 3 characters, and define the file's permissions. The first section determines the permissions of the file or directory owner, the second section for the group ownership permissions, and the third for everyone else permissions. Each section can have either the R, W or X flag set, so a permission like this would mean anyone could read and write to that file. Or this permission means that only the user can read and write the file, and group members can just read. The X flag, when applied to a normal file, means allow execute, and is used for shell scripts and binaries. So this would mean both the owner and group members can execute and read the file, and only the owner write to it. When using the X flag on directories, it means allow access to that directory. So for example, the root user's home directory has this permission, which means only the root user is allowed to enter that directory. There's also some special flags that can be set, which are called the SUID, group ID and sticky bits. If you see a file with an S replacing the X in the owner section, it means that the executable will run with the owner's effective ID, or SUID bit. Adding an S to the group section on a file means the executable will run with the group ID. Adding an S to the group section of a directory means any files created under that directory will inherit the group ownership of the directory. Linux doesn't support setting the SUID bit on directories, but this is sometimes supported under other Unix systems. The last flag is the sticky bit. When applied to a directory, any file created under that directory can only be removed by the owner, regardless of any other permissions set on the file. Linux will ignore the sticky bit when set on a file. Permissions are important for security, so make sure they are correctly set. All users are restricted by file and directory permissions. The only user that isn't is the root user, which has complete access to the system. Earlier on, I mentioned hard links and symbolic links. Symbolic links are special files that allow you to reference another file or directory. Of course, the reference can be absolute or relative. Be careful when using symbolic links, as you can end up with an endless loop. If you remove the file being linked to, the symbolic link will remain but point to nowhere. Hard links are like symbolic links, but they aren't a virtual file and so don't consume any disk space. They appear on the file system as a real file. Like symbolic links, you can have as many as you like, but if you remove one of the hard links, the others remain. Essentially, every file that you create on a file system has a link to start with, so a hard link just adds another reference. However, under Linux, you can only hard link a file and not a directory. Directories will always contain links to other directories. So going back to the ls-l command output, we see that this directory claims to have 5 links. If we look at the contents, yep, we can see the 5 directory links. Using the ext4 file system, the default maximum number of links is 64,000. But generally, you want to avoid this, as searching through a directory with that many links is very slow. Now that you have an understanding of how to navigate a Linux file system, here's a couple more basic commands that you might use. Okay, I have to comment on the last command. This is one of the particularly dangerous ones. When I was managing a team of Unix sysadmins, I'd always say to them, never use relative addressing when using the -rf flags for RM. The reason is that the -r implies recursive and the -f implies force, which means it will not prompt you. One of the worst mistakes I've seen is something like this: rm-rf star cd/bang rm. Under bash, the bang or exclamation mark means repeat the last command in the history that starts with whatever follows. In this case, it would be translated to rm-rf/star, which will remove the whole file system starting from root. Everything, all gone with one command. It's always important to remember that the root user can do anything under Linux. So I'd suggest that until you're very familiar with Linux, just use a normal account, such as the Pi user on Raspbian. You can always use sudo to gain root privileges, but try to keep that to a minimum. Also, don't blindly execute scripts and commands from websites. Make sure you know what it is doing before you do it. So that's it for this video. In the next video, we'll be taking a further look into the most common shell used, which is bash, and delving into some basic shell scripts. Thanks for watching, and see you next week.